Okay. Okay, we are starting our discussions with the topic differential equations. Differential equations. Okay, what is differential equation? What is the use of differential equation? First of all, they are used to represent some change. Used to represent change. Okay, suppose a person is standing here and he start walking. We wanted to measure his distance, that distance covered by this person with the time. So we are measuring the distance covered by the person with the time. So we are interested to define a quantity called as speed or velocity, which is dx by dt. So this gives you the change of displacement with respect to time. Okay, so this expression is used to represent a change. So similar way, all the differential equations, if you define, will have two variables. One is called dependent variable and other is called independent variable. And dependent variable will change with respect to independent variable. I will come to that. So usually differential equations are used to represent a change. Okay, what is the mathematical definition for a differential equation? The mathematical definition goes like this. An equation, differential equation is an equation involving derivative of dependent variable with respect to independent variable. One variable changes with respect to other. One is called a dependent variable and other is called independent variable. Usually, if you wrote an expression dy by dx, this is called dependent variable. Dependent variable that changes with respect to this, which is independent variable. Okay, so an equation involving derivative like this, a dependent variable with respect to independent variable, is called a differential equation. For an example, for a differential equation, we could write, say, x dy by dx plus y equal to 0. Here we have dependent variable y, independent variable x, and this equation, entire equation containing that particular requirement. That equation contains derivative of this. So this is an example for a differential equation. Okay, so ഇത്രയേ ഉള്ളൂ. ഡിപ്പെൻഡന്റ് വേരിയബിളിന്റെ ചേഞ്ച് ഇൻഡിപെൻഡന്റ് വേരിയബിളിന് വിത്ത് റെസ്പെക്ട് നമുക്ക് എടുക്കേണ്ടി വരും. ആ ഡെറിവേറ്റീവ് ഇൻക്ലൂഡ് ചെയ്യുന്ന ഒരു ഇക്വേഷൻ വിളിക്കുന്ന പേരാണ് ഡിഫറൻഷ്യൽ ഇക്വേഷൻ. അതാണ് അതിന്റെ കൺസെപ്റ്റ്. സോ we are looking, or we are more interested with the ordinary differential equations. Ordinary differential equations. In ordinary differential equation, it is a differential equation involving derivative of dependent variable with respect to independent variable. But there is only one independent variable is present. Okay. So this take derivative of dependent variable with respect to only one independent variable. Okay, for example, say dy by dx whole square plus dy by dx, say 2 dy by dx plus y equal to 0. Here if you see, y is the dependent variable, that derivative of y include only x. So this is ordinary differential equation. So a differential equation involving derivative of dependent variable with respect to only one independent variable, then it is called ordinary differential equation. What if the dependent variable depends on or which containing more than one independent variable? Then it is called a partial differential equation. We will look into this later. Partial differential equation. Simply, you know what is partial differential equations? A differential equation involving partial derivative. A differential equation involving partial derivatives. You know that d square dou square by dou x square psi plus dou square by dou y square psi plus something 2 psi equal to 0, something like this. So here if you see, this psi depends on x and y. We are taking the derivative with respect to x and y. Okay, so here psi, which is the dependent variable, and the derivative with respect to x and y are taken. Independent variables are x and y. There are two independent variables. So such differential equations are called partial differential equation. These are just classifications. Okay. So ordinary differential equation എന്ന് പറഞ്ഞാൽ എന്താണ്? അവിടെ ഒരൊറ്റ ഇൻഡിപെൻഡന്റ് വേരിയബിളെ ഉണ്ടായിരിക്കത്തുള്ളൂ. പാർഷ്യൽ ഡിഫറൻഷ്യൽ ഇക്വേഷൻ ആണെങ്കിൽ നമ്മുടെ ഡിപെൻഡന്റ് വേരിയബിളിനെ ഒന്നിലധികം ഇൻഡിപെൻഡന്റ് വേരിയബിൾ വെച്ചിട്ട് ഡിഫറൻഷിയേറ്റ് ചെയ്യേണ്ടി വരും. ദാറ്റ്സ് ഇറ്റ്. Then now comes the major question. Why we study differential equation? Why differential equation? Why physics always studying differential equations? So if you ask this question, we are starting from the beginning. The fundamental equation in mechanics, which is F equal to ma, Newton's law. Newton's law. Okay, without Newton's law, we cannot say anything in physics. We can study quantum mechanics, no problem. But for an ordinary man living in this physical world, Newton's equations are very important. Okay, so if you look at this acceleration, this term, that is actually rate of change of velocity. So speed or velocity with changing with respect to time, or it can also written as d square x by dt square. So Newton's equation is simply a second order differential equation. So once you solve this, this equation, we get x as a function of time. We get something. If you give the time, we can predict the particle's position. That is the beauty of Newton's equation. Okay. Now we will look into more examples from physics. Rate of from thermodynamics, we will start thermodynamics next week. Rate of flow of heat through a pipe. You are familiar with this equation, which is regarding the heat flow. dq by dt, where q is the heat flowing through a medium, flowing through the pipe, that is equal to some constant area of cross section of the pipe into temperature gradient dt by dx. Okay, where k is a constant called thermal conductivity of the medium. Thermal conductivity. dt by dx is, you know what is temperature gradient. Temperature gradient. How the temperature changes with respect to distance. Okay, so even in thermodynamics, we have to solve this differential equation. What do you get from this? Once you solve, you get q as function of time, some function of time, or you can solve this equation and you can get temperature as a function of distance. Two possible solutions are we can obtain from this differential equation. So in thermodynamics, we need differential equation. In mechanics, we need differential equation. I would like to give one more example from electronics. Suppose I am taking LCR circuit. Okay, a circuit containing resistance. It is very familiar circuit for you. That's why I'm taking LCR, an inductor and a capacitor. Okay. So when current flows through this, the resistance is represented by R and the voltage drop across is IR. And this is capacitance, and a capacitance drop a voltage VC, which is charge stored by capacitance of the capacitor. And inductor, a potential drop across, which is represented by VL, which is nothing but inductance L di by dt. Okay, this is Now, if we apply the Kirchhoff law, you know that the sum of the voltage drops across all the component is equal to net voltage applied. That is V equal to VR plus VC plus VL, right? So V equal to, what is our VR? If I write that, I got RI plus VC is just Q by C plus VL is L di by dt. If you see, this is a differential equation in terms of current. But we can modify this one. If you see I equal to dq by dt, if you substitute this one in the here in terms of I, then that equation will modify again. I will write it here. L d square q by dt square plus, here is also I dq by dt plus, here is q only, q by c equal to v. This is another form of this same differential equation. This, once you solve, you get I. Here, once you solve, you get q. That is a difference. Okay. So what I mean is, in physics, if you go to every branch, you cannot get away from the differential equation. If you enter into the world of quantum mechanics, the Schrodinger equation itself is a differential equation. You are very familiar with the Schrodinger equation, which is h psi equal to E psi. So which is nothing but minus h cross square by 2m d square psi by dx square, right, equal to minus ih cross, I'm sorry, ih cross dou by dou t, ih cross dou by dou t plus psi. So this is again a differential equation. So in every branches of physics, we need differential equation. Yesterday, we started simple harmonic motion, right? So sir told you, if you have a spring and if you apply some force in this direction, this is applied force, the spring itself develops a restoring force in this direction. So if the particle is displaced by this amount x, then the restoring force is proportional to the displacement but in opposite direction. So if you know that F is equal to m d square x by dt square, so that will gives you m d square x by dt square. Say I'm writing f equal to some constant minus kx. Okay, that will be equal to minus kx. That gives you the wonderful equation x double dot, that is d square x by dt square plus k by m, x is equal to 0. This is actually differential equation of second order. Okay, yesterday you directly, sir told you the differential equations, the solution of the differential equation directly, but we know, we will learn how to solve this differential equation. Okay, so these are the importance of differential equation, and we will solve some problems soon. So we cannot avoid a differential equation from any branch of physics. Okay, അപ്പോൾ ഇതുവരെ നമ്മൾ ഒന്ന് സംസാരിച്ചത് ഡിഫറൻഷ്യൽ ഇക്വേഷന്റെ ആവശ്യകതയാണ്. അത് ക്ലിയർ ആണെന്ന് വിചാരിക്കുന്നു. ഇതിൽ കൂടുതൽ മലയാളം വേണ്ട കാര്യമില്ല. പല ബ്രാഞ്ചുകളിലും നമുക്ക് ഡിഫറൻഷ്യൽ ഇക്വേഷന്റെ ആവശ്യകതയുണ്ട്. മാത്തമാറ്റിക്സ് ആയതുകൊണ്ട് അധികം മലയാളം ഇല്ലെങ്കിലും ഓക്കെ ആണെന്നാണ് എൻ്റെ വിശ്വാസം. ഓക്കെ, നൗ we will go to some parameters about the differential equation. First one is order of differential equation. Order of differential equation. Okay, what do you mean by order of differential equation? First I would like to define this. It is the order of the highest order derivative, or it is the order of the highest order derivative in the differential equation. In differential equation. in the given differential equation. Okay, so that is the order of the differential equation. So for example, we can say differential equation dy by dx equal to something e raised to x. So this differential equation containing only one derivative. What is its order? Dy by dx. Order is 1. So order is 1. One more example I will tell you. D square y by dx square plus dy by dx plus 2y equal to 0. Here, this differential equation containing two derivative terms, 1 and this one is 2. We want order. Order of the differential equation is order of the highest order derivative. The order of this derivative term is 1. Here you can see order is 2. So which one is highest? 2. So order of this differential equation is 2. Okay, I hope that concept of order is clear for you, right? Now, we are introducing a new concept called degree of differential equation. Degree of differential equation. Okay, we will go. So before introducing degree, I would like to say not all differential equation, the degree is not defined. So in order to define degree, there are some requirements. I will point out one by one. Okay, to define degree, the differential equation must be a polynomial in derivatives. Okay, I will make it clear. To define degree, the differential equation must be a polynomial equation. Polynomial equation in derivatives. Say y prime, y double prime, y double triple prime. So in terms of this, the differential equation should be polynomial in terms of this. Okay, otherwise we cannot define the degree of the differential equation. Otherwise means if the differential equation is not a polynomial in derivative, otherwise we cannot define degree. Okay, we will come to the example. For example, what is a case we cannot okay, wait. Example we can take, this is d square y by dx square plus 2 dy by dx plus y equal to 0. If you see this here, y double prime plus 2y plus y equal to 0, y prime. So this is actually a polynomial in derivatives, right? So here the degree is defined. So degree defined. Degree can be defined. Okay. What is degree? I will tell you in a minute. Wait. Now, if I take another equation, say dy by dx plus sine dy by dx equal to 0. Here, if you see y prime plus sine of y. This is not a polynomial in derivative. I'm sorry. Y prime. So this is not a polynomial in derivative that containing y prime inside that argument of psi. So this is not actually a differential equation with a definable degree. We cannot define degree of that differential equation. Okay. Now I would like to give what the definition of what is the degree of a differential equation. Okay. The definition of degree. Degree is the highest power of the highest order derivative. Degree is the highest power of the highest order derivative, provided when the differential equation is free from fractional powers. Fractional powers. Our differential equation should not containing any fractional powers. Then degree is the highest power of the highest order derivative. Okay. You will the idea will be clear when we solve some examples. Okay. For instance, please carefully listen to this definition. Okay. We should not have any radicals. It should be free from fractional powers. For example, if I give you this differential equation, say d square y by dx square whole cube plus 3 dy by dx plus 4 d square y by dx square plus 5y equal to 0. So if I give this example, degree is the highest power of the highest order derivative. What is the highest order derivative? Here there is no order 0. Here order 2. Here we have order 2. So highest power of the highest order derivative. Here power is 1. Here power is 3. First, you have to identify the highest order derivative term, this and this. And among those highest order derivative terms, you have to take highest power term. So this is 3. So degree here is equal to 3. Okay. So I hope the idea of degree is clear, and we will discuss a few questions about this. Before that, you have to keep in mind one thing about order and degree. It's a note. Order and degree of differential equation is always integers, positive integers. Order and degree of differential equations are always positive integers. Always positive integers. Okay, so this is all about our differential equations. Okay, so we can have some examples. Find order and degree if defined of following differential equations. Okay, so first example, dy by dx minus cos x equal to 0. So this is the first one. What is the order of the differential equation? The order of the highest term, the highest, or the order of the highest order derivative, which is 1 here. What is degree? Is degree defined? Of course, degree is defined because this is a polynomial in derivative. So degree of this differential equation is just highest order differential, this one. So and the degree of this differential equation is 1. Okay, so I will give a next question. So x y double prime plus x y prime whole square minus y prime equal to 0. What is the order? To find order, you just check what is the highest order derivative. This term having double derivative, so order 2. This term having only one derivative. Here also. Is degree defined here? Of course, this is a polynomial in derivative, right? So degree is also defined, and the degree is the power of the or order of highest order derivative, which is 1. So degree of this differential equation is 1. Okay. So next example, y triple prime, y triple dash, and y square plus e y prime equal to 0. Of course, the differential equation, if you look, the highest order is y triple prime, right? So order is just 3. Is degree defined here? No, because the differential equation should be a polynomial in derivative. If you look at the derivative terms, so this is not a polynomial in derivative because of the presence of this term. So in this case, degree not defined. not defined. We cannot define the degree in this case. Okay. So we will discuss more type of questions. Wait a minute. I will take some questions. Okay. Please simplify d square y by dx square whole power 3 dy by dx plus 5y equal to 0. Okay, you just try. I will discuss one by one. Dy by dx plus 5y equal to 0. 6 d square y by dx square plus 5 dy by dx whole power 1 by 2. Something different here. Plus 6y equal to 0. Okay, first we can have a look into these three. So this is a very simple one. Order, if you look, highest order derivative is second order, right? So 2. This is a polynomial in derivative, no problem. So degree is defined. So degree equals highest order derivative having power 3. And this is order 1 and degree is of course 1. I hope that is clear. Here if you see the order of this differential equation 2, but here we have a fractional power. So if you look at the definition of our degree is the highest power of the highest order derivative when the differential equation is free from fractional power. Suppose if you have a fractional power in your differential equation, you have to make it free of the fractions. It means the 1 by 2 is here, so make it an integer. How we can make it an integer? Before multiplying it with the 2. Okay, so what happened then? Then every differential term whole square. Okay, every differential term we have to multiply with the 2. So 5 dy by dx 1 by 2 into 2 plus 6y equal to 0. So if you do that, you will get y double prime whole power 2 plus y prime whole power 1 plus 6y equal to 0. Now your differentials are free from radical. Okay. So you can see here order of the differential equation is 2 and degree of differential equation, of course, the highest order derivative having the power 2. So degree is 2 in this case. Okay. So you should not answer from here because it contains some radical. Okay. We will discuss some questions like this. Say 7 d square y by dx square whole power 2 by 3 plus 5 dy by dx plus 6y equal to 0. Okay, we can go one by one. Here we have 2 by 3. So if you multiply with 3 by 2, that will be okay. But the problem is that you will get a 3 by 2 here. So that is not a good way. So I am just multiplying with 3 only. So d square y by dx square. Disturbance. Oh, is it okay now? Oh, the problem is some of you turn on the mic after joining. When his mic is on. I forgot to. Wait a minute. It happened for a long time. Kore neramayo ee disturbance തുടങ്ങിയിട്ട് അതോ ഇപ്പോ തുടങ്ങിയതേ ഉള്ളോ? ഒന്ന് കമന്റ് ചെയ്യാമോ? ജസ്റ്റ് ആണെങ്കിൽ നമുക്ക് Korachai. Okay. Should I repeat all these things? ഏത് തൊട്ടാണ് പ്രശ്നം വന്നേ? ഞാൻ അത് ഒന്ന് ഡിസ്കസ് ചെയ്ത് തരാം. ഈ നോയ്സ് പ്രോബ്ലം വന്നത് ഏത് തൊട്ടാണ്? സിക്സ് പ്രോബ്ലം. അതിന് മുന്നേ വോയിസ് പ്രോബ്ലം ഉണ്ടായിരുന്നോ? സിക്സ് തൊട്ടാണ് വന്നത്. ഓക്കെ, ഇനി ആരും മീറ്റിംഗിലേക്ക് ജോയിൻ ചെയ്യാതെ ആക്കി വെക്കാം. ഒരു മിനിറ്റ്. Okay, I will discuss from 6. Sorry for that disturbance. Okay. Which is a sixth problem. Okay, the sixth one. The sixth one I will discuss again. 6d square y by dx square plus 5 dy by dx whole power 1 by 2 plus 6y equal to 0. Okay, now if you look this differential equation, it is not free from radical. It containing some radical power, so we have to make it free from radical. So I am multiplying with the 2 first. So this become d square y by dx square, only the differential terms multiplied with the 2. So plus 5 dy by dx plus 6y equal to 0. Once you multiply with the 2 in the power, that 1 by 2 will goes to 1, right? So now it is free from the fractional powers. Therefore, order of the differential equation is highest order derivative is 2. Degree of the differential equation is power of highest order derivative, that is also 2. I hope that point is clear. Okay, we will discuss more problem related to this. My seventh problem is also something related to this concept. D square y by dx square whole power 2 by 3 plus 5 dy by dx plus 6y equal to 0. Okay, so here if you see, we have a fractional power 2 by 3. To find the degree, we have to get rid of that fractional power. So there are two choices. You can multiply with the 3 or 3 by 2. If you multiply with the 3 by 2, a 3 by 2 will come here, again fraction. So we are going into more trouble. So we are just multiplying with the 3. So once you multiply with the 3, that will become d square y by dx square. Multiply with the 3 means the power. Okay, so once you multiply this power with the 3, this become 2 plus 5 dy by dx 3 plus 6y equal to 0. So what is the order? Highest order derivative is 2. What is degree? Order of highest order derivative. So power of the highest order derivative. So highest order derivative is 2, its power is again 2. So order and degree of this differential equation is also 2. Okay, so if more than one term containing fractional power, what happened? So we have an example like that. Say d square y by dx square whole power 1 by 2 plus 5 dy by dx whole power 2 by 3 plus 6y equal to 0. Okay, so this is a case. Now, if you see two terms containing fractional powers, so what we have to do is take the LCM of these fractions and multiply with that LCM. If you multiply with the 2, this fraction won't go. If you multiply with the 3, this fraction won't go. So if you take the LCM of this 3 and 2, which is 6. So you have to multiply with the 6. Okay. So that become d square y by dx square 1 by 2 multiply with the 6 plus 5 d square y dx all power 2 by 3. The power is multiplied with the 6 plus 6y equal to 0. That's it. So that will gives you y double prime power 3. 1 by 2 into 6 is 3 plus 5 y prime. This once you multiply, you get 4 plus 6y equal to 0. You just look into this term because we need only this term, right? Provided all other terms are free from fractional powers. So here, if you look, order is 2, degree is 3. Okay. Hope that concept is very clear to you. And now we'll move to one more example similar to that. The last one, d square y by dx square. Let me take the question. 2 by 3 plus dy by dx 3 by 2 plus y equal to 0. Okay. Here also, if you see 3 and 2, so take the LCM 6. So if you do that, d square y by dx square, multiplying the power with the 6, you will get 4, right? Plus dy by dx, you get 9 plus y equal to 0. So order is still 2. Degree of this differential equation is just 4. Okay, this is the way to find the order and the degree of the differential equations. I hope the idea is clear to you. Order and degree summarize order in the differential equation highest order derivative order degree in or a differential equation highest order derivative in the power. Okay. Provided our differential equation fractional powers degree define that differential equation should be a polynomial in derivative. This is two degree define examples examples clear powers fraction simple differential equation without any fraction, then solve you will get the order and the degree of the differential equation. Okay. Now we are interested, the physics people are interested in linear differential equation. Okay, because it is having many practical application. Linear differential equations. Linear differential equation. Okay, a differential equation of the form, say this is a general form, a0y, you should be very careful about this, a1 y prime plus a2 y double prime plus a3 y triple prime, etc. equal to some b, where this a's and b, a0, a1, a2, a's and b, they may be constants, or functions of independent variable. Okay. Then only this differential equation is linear. Listen. the differential terms are there, and the coefficients must be a constant or functions of independent variable. Then only the differential equation is linear. If you see what is the degree of differential equation, if you see highest order derivative is higher, many terms. I say last time I can say a n, y n. Then the order of this differential equation is n. But what is the degree? 1. So for a linear differential equation, the degree should be 1. What is the limit to its order? Order can be anything. Order can be anything. So one more point you can note from here that coefficients of the derivative terms should be a constant or functions of independent variable. Coefficients are constants or functions of independent variable. Okay, so this is what all about the linear differential equations. If it is a function of dependent variable, then we cannot say this represent a linear differential equation. Okay, so what is a non-linear differential equation? Non-linear differential equation, we are not going to discuss this now. A non-linear differential equation is a differential equation which is not linear. Which is not linear. A differential equation which is not linear is called a non-linear differential equation. For instance, that definition is enough for us. Okay. Now I will give you some questions. You can do. You have to find out whether it is linear or non-linear. Find the given differential equations are linear or not. Okay. So my first question is this: dy by dx plus 5y equal to 0. So the order is 1 and the degree 1, and the coefficient is just a constant. Here, what is the dependent variable y? Independent variable is x. Okay, no problem here. And the y, the presence of y making any trouble? No problem, because if you see the definition, a term with y is also there. Okay, so y power 0 or y power 1, that term can be there. Okay, so no problem with this. This represent a linear differential equation. Of course, it is a linear. Okay, now I go to another example. Dy by dx plus xy square equal to 0. So if you check the order, okay, is 1, and the degree is also 1, no problem for that. Order can be any, no problem, but here it is 1. But if you have a problem here, the presence of y square, there should not be any y square term in a linear differential equation. So this is non-linear because presence of y square make it non-linear. Okay, our general form takes a naught y plus a1 y prime dy by dx plus a2 y double prime and so on equal to b. So there is no y square or higher terms of y. Okay, so this is non-linear differential equation. Now dy by dx equal to cot y. Is it? If you rearrange, we get dy by dx minus cot y equal to 0. The coefficients are either constants or functions of independent variable. Now you have a function of dependent variable here. So this is again non-linear differential equation because of the presence of O to y. Make it non-linear. Okay, next one, a simple one. Y prime equal to 1. Of course, it is non-linear. Why? Because the coefficient is a function of y. So non-linear because y prime term. Make it non-linear. Then fifth one, y prime square equal to xy. Is it a linear or non-linear? Non-linear. Why? Order is 1, no problem. But the differential equation is linear provided its degree should be 1. If you look at here, the degree of this differential equation is 2. Degree equal to 2. So this is a non-linear differential equation. Okay. So നിങ്ങൾക്ക് ഈ ഭാഗത്ത് നിന്ന്, അതായത് എൻ്റെ ഇവിടെ നിന്നുള്ള നോയ്സ് പ്രശ്നമാകുന്നുണ്ടോ? ഒന്ന് കമന്റ് ചെയ്തേ. വേറെ നോയ്സ് കയറി വരുന്നുണ്ടോ? അങ്ങനെയെങ്കിൽ നമുക്ക് സ്റ്റോപ്പ് ചെയ്യാം. നോയ്സ് ഇല്ലാത്ത സമയം ചെയ്യുന്നതാണ് നല്ലത്. വേറെ പ്രശ്നമൊന്നുമില്ല. അതായത് ഇവിടെ മിക്സിയുടെയൊക്കെ സൗണ്ട് ഒക്കെ ഉണ്ട്. നിങ്ങൾക്കത് പ്രശ്നം തോന്നുന്നുണ്ടോ? ഐ മീൻ നിങ്ങളത് കേൾക്കുന്നുണ്ടോ? Okay, then we can continue, right? Now we will introduce a new concept, which is solution of a differential equation. What do you mean by the solution of differential equation? Suppose we have a differential equation in x and y. Let we have a differential equation in x and y. Say dy by dx equal to something, f of x or something. Okay. So the solution of this differential equation means a relation between dependent variable and independent variable. Solution of a differential equation means a relation connecting dependent and independent variables. Independent variables. Okay. In our case, for this equation, once you solve, you get y equal to some f of x. A relation connecting the dependent variable and independent variable. Okay. So the solution of the differential equation is the relation between dependent and independent variable when substituted into the differential equation. And we will get an identity. Once this relation substituted into given differential equation, we get an identity, which means it will satisfy. Okay. If we have a solution, then if substituted back to the differential equation, that differential equation should satisfy the solution. Okay. I will give you an example. Let say y equal to sine x plus c is a solution of the differential equation y prime equal to cos x. If this is the solution, Once you substitute this solution in this differential equation, this should satisfy. So we need something y prime equal to cos x. This is the given differential equation. Our solution is y equal to sine x plus some constant. So I am differentiating y prime, which is equal to cos x. So they are same, which means if you take y prime and substitute it here, you get cos x equal to cos x. You get an identity, right? Which means this is the solution of the given differential equation. Okay, so we can have a question here. Question: check whether y equal to a e raised to x plus b e raised to minus x is a solution of differential equation y double prime equal to y. So we have to check whether it is a solution of this differential equation or not. Okay, so we are starting with our solution y equal to a e raised to x plus b e raised to minus x. In order to verify whether it is a solution or not, we need the second derivative term. Therefore, I am taking the first derivative, which is a e raised to x plus b e raised to minus x into minus 1, right? So if I take one more derivative, I get a e raised to x plus b e raised to minus x. Minus 1 is there, also a minus 1 is introduced from this e raised to x, right? Therefore, I get y double prime equal to a e raised to x plus b e raised to minus x. Okay. So if I substitute this y double prime in this differential equation, y double prime equal to, what is y double prime? A e raised to x plus b e raised to minus x. But this is nothing but our y. So we will get our differential equation back. That means the solution, once I substitute into this differential equation, satisfy this form, which means this is the solution of the differential equation. I introduced this very simple idea because during the examination, you are required to find the solution of some differential equation. Suppose you forgot about that method. Some differential equation has to be solved in a particular method. Suppose you forgot. What do you do? You just take the option and just substitute those options in the given differential equation. That will gives you the answer. Okay. You can go reverse way, taking the option and put back to differential equation and solve. That will take some time, but you will get the answer. Okay. Now, I would like to introduce a new concept, which is types of solutions. Types of solutions. In general, there are two types of solutions. One is general solution and another is particular solution. General solution and a particular solution. We will come to this. Okay, in generally, a linear differential equation of order n containing n constant. Okay, a linear differential equation of order n contains I'm sorry for this, I'm adding one term, solution of a linear differential equation of order n contains n arbitrary constant. N arbitrary constants. A solution with the arbitrary constants is called a general solution. a solution with arbitrary constant. Constant is called general solution. Okay. At the same time, we are picking the solution corresponding to a particular constant value, then that is called a particular solution. The solution obtained from the general solution for a particular value. Particular value of what? Particular value of arbitrary constant. Arbitrary constant. This is called a particular solution. The solution obtained in such a way that is obtained from the general solution by picking a given value to the arbitrary constant. Okay, that is called a particular solution. This concept will be clear while we're discussing the problem. Okay. Wait. Okay. So before that, we will doing this, I would like to give some question. Okay. These concept we will do. Wait. Question. Verify y equal to e raised to minus 3x is a solution of y double prime plus y prime minus 6y equal to 0. Okay. So how do you do? You have this is given as solution e raised to minus 3x, right? So first you have to take derivative because you need a derivative, second derivative and all. So once you take the derivative, you get minus 3 e raised to minus 3x. If you take the derivatives twice, you get minus 3 again, that become 9 e raised to minus 3x. So substitute in this equation y double prime plus y minus 6y equal to, we have to get 0. If we get 0, this is the solution of this given differential equation. We can check what is y double prime. 9 e raised to minus 3x plus what is y prime? Minus 3 e raised to minus 3x plus, sorry, minus 6y. What is y? E raised to minus 3x. So that gives you minus 9 3x, 9 e raised to minus 3x minus 9 e raised to minus 3x. This is 0. So y double prime plus y prime minus 6y equal to 0. We get our differential equation. It is satisfied, which means this is a solution of the given differential equation. Okay. So I will give you solution. You have to check whether it satisfies the differential equation or not. Okay. Next question. Y equal to a cos x plus b sin x. Check whether it is the solution of the differential equation d square y by dx square plus y equal to 0. Okay. So we need double derivative, right? So take first derivative. What do you get? Cos x derivative minus sin x. So a is a constant and I get minus sin x plus b sin x derivative is cos x. We need second derivative. So y double prime equal to minus a sin x derivative cos x. Cos x derivative is minus sin x. If you substitute this term back to this equation, y double prime, which is minus a cos x minus b sin x plus y. What is y? This a cos x plus b sin x equal to wait equal to what? This will cancel, equal to 0. So this equation is satisfied, which means the given equation is the solution of our differential equation. Okay. Now I will give you a concept called boundary condition. Boundary condition. What are boundary conditions? Boundary conditions are set of values which are to be satisfied by a particular solution. Mathematically, this is a definition. The conditions which are to be satisfied by the particular solution. Okay. For example, how the boundary condition arises. This is actually arises from physics. If you take a gas and enclosed in a container, what is a boundary condition? The gas molecule, suppose there is a ball, okay, ball. This ball can move here, suppose x equal to 0 and this is x equal to L. So movement is restricted between x equal to 0 and x equal to L. So this is a boundary condition. Suppose you are studying mathematics and you get bored and you plan to jump from the top of a building, say it's a negative one, say consider this. What are the conditions? Suppose a person is here, your sir is here to measure how fast you are falling down. Okay. So how we calculate? He put the condition. He is a physicist. Okay. So he will measure your G is only gravity pulling you. He neglect all the air resistance. Then d square x by dt square. He will formulate a differential equation to solve this problem. Once he solved, this is a differential equation in second order, right? So how many constants will come? 2 constants will come. So he have to remove this constant. In order to remove this constant, he will assume some condition. What is the first condition? You are initially at rest. Your initial position, he will take it as 0. Initial position, he will take it as 0. Which means at time t equal to 0, your initial position is 0. This is a condition. This condition helps to give the value of a constant. But we need 2 constants. So to get complete solution, we need at least 2 conditions. Suppose there are n constants, we need n conditions. If there are 2 constants, we need 2 conditions. Okay. Can you find one more condition? Of course. His initial velocity is 0, which means at a time t equal to 0, x dot, which is dx by dt, this term is 0. These 2 conditions together will give you the constant value. Okay. These are the boundary conditions, the conditions which are satisfied by the particular solution. Once we substitute these conditions to the general solution, we will get the value of the constant. Okay. So we will discuss one problem, then you will get the complete idea about the boundary condition. Question. An object falls freely under gravity from the top of a building. Same problem we discussed, right? Find the distance traveled. Distance traveled in t seconds. T seconds. Starting from rest. Okay, starting from rest is actually no need because it is fall freely. Fall freely means initial velocity is 0. Okay, an object falling down from the top of a building. Okay. So after time t, what is his position? This is the question. So we are physicists. We are given a problem. So we have to make the solution. First, we have to think about the physics behind this problem. If you look at this problem, oh, there are many problems. First, the air resistance is a major problem. Suppose there is wind, we cannot measure it accurately. So first, we have to identify those noises and remove. And we make the problem ideal. Okay. For instance, for easiness of the problem, we will include the air resistance later. But for instance, suppose there is no air resistance, then I could say that the acceleration of the particle is given by d square x by dt square, but acceleration is nothing but g. Acceleration will be gravity. Okay, so d square x by dt square equal to g. So I integrate one time with respect to time, then I will get dx by dt, right? So I get dx by dt equal to gt plus some constant. I call it as some v naught. Okay, v naught. What is dx by dt? We are physicists, we know that v, which is velocity, equal to gt plus v naught. Okay, gt plus v naught. We are moving again. We want to find the time, so we are differentiating again. Sorry, integrating again. I get, once I integrate this expression, I get x of t, which is equal to g t square by 2 plus v naught t plus some constant. I call it as x naught. I deliberately used v naught and x naught because I am a physicist. I know what does it mean. Okay. Now we have two constants, v naught and x naught. To get the constant values, we have to use the boundary conditions. Sometimes the boundary condition may be given to you. Sometimes they are not given to you. So you have to find from the problem. Now we can find the boundary condition from the problem. What is the boundary condition? At a time t equal to 0, your x is equal to 0, right? That will give you, if you put time t equal to 0, your x equal to 0, that 0 equal to time 0 plus time 0, this term 0, x naught 0. So which means the constant x naught is 0. What does it physically mean? Initially, the position of the particle is 0. We are taking origin here. That's it. So we are left with this solution. G x is equal to gt square by 2 plus v naught t plus v naught t. So to get one more boundary condition, sorry, we have to get this equation, right? So that I am taking the derivative x naught, x dot, that is taking the derivative, I get gt plus v naught. I know that at t equal to 0, the velocity of the particle x dot is also 0. If I substitute this condition, I get in this equation 0 equal to 0 plus v naught. That means v naught equal to 0. Physically, it means initially its velocity is 0. Now I can put it back to this equation. This is our required equation. X of t equal to half gt square. This represents the position of the particle with respect to time if it is falling freely from the top of a building. So I hope the idea of boundary condition is clear for you. Okay. In some problems, these boundary condition may be given to you. In some other problems, they won't given to you. You have to find out. Okay. So we can wind up our discussion with a few more questions. Okay. I will discuss one more question. The solution of differential equation. The solution of differential equation y double prime equal to y, which passes through the point log 2 3/4 if the general solution is someone asked some question. Oh, I will take air resistance for the condition we will discuss in mechanics. We will come to that point in mechanics. Okay, don't worry. Or we will do that. We have previous questions. We have to account the air resistance. And we have a special kind of differential equation called a linear differential equation. In that case, I will discuss the air resistance as a condition. Okay. Now I just convey you how to use these boundary conditions properly. Okay. So I will come to that point. Don't worry. Now, this solution of the general solution is given to you, which is y equal to a e raised to x plus b e raised to minus x. Now we are not familiar with solving the second order differential equation. Therefore, the general solution is given. Okay. Now you have a differential equation. This, once you solve, you get a general solution a e raised to x plus b e raised to minus x. But we are required to find the particular solution. The solution of the differential equation passes through this point. E point will pass in the solution. So this is the boundary condition. So we can make use of that. Okay. Oh, I'm sorry. One more condition is given, which passes through the point this and origin. Question is this: the solution of differential equation y double prime equal to y, which passes through the point and origin, if the general solution is this. So it passes through origin. What does it mean? Passing through origin. What does it mean? How we can formulate a condition which means origin 0 0, which means at x equal to 0 your y should be 0. This is a condition. So once you substitute, you get 0 equal to a e raised to 0 plus b e raised to 0. That is 0 equal to a plus b. That is your b equal to minus a. So we can formulate, we can get rid of one constant now. A e raised to x and b equal to minus a e raised to x. So this is just a e raised to x minus e raised to minus x. Now the second condition that is passing through the point log 2 3 by 4. That is when x is equal to log 2, the y equal to 3 by 4. That is a meaning. So we can substitute y equal to 3 by 4 when, I'm sorry for this, 3 by 4 when your x is equal to log 2, e raised to log 2 minus e raised to minus log 2. So 3 by 4 equal to a, e raised to log 2 is just 2 minus, you can take this minus here. So e raised to log to the power minus 1, that will be 1 by 2. So you get 1 by 2 here. That is 3 by 4 equal to a into 3 by 2. 3 will cancel and your a will be 1 by 2. So we got the particular condition and a particular solution. Y equal to, this is our solution, a e raised to x minus e raised to minus x. So a equal to 1 by 2 and e raised to x minus e raised to minus x. So this is. So this is the particular solution of our given differential equation. Can you simplify it further? Of course, this is nothing but sine hyperbolic, right? Sine hyperbolic. This is a solution. Okay. So this is where we have to apply the boundary conditions to the given differential equations. Okay. For instance, we are stopping here and we will discuss the different types of linear equations in the next session. Probably we will finish the variable separable method, and if time permits and if you are ready, we will go to linear equations. Okay, once these differential equations are over, we will do some previous problems.
നമ്മൾ ഡിഫറൻഷ്യൽ ഇക്വേഷൻസിൽ നമ്മൾ എക്സാമ്പിൾ ആയിട്ട് പ്രോബ്ലംസ് ചെയ്തിട്ട് പ്രീവിയസ് എല്ലാം കൂടെ ഒരൊറ്റ ഇതായിട്ട് അങ്ങ് ചെയ്യും. അതാണ് ഉദ്ദേശിക്കുന്നത് കേട്ടോ. എന്തെങ്കിലും സംശയം ഉണ്ടെങ്കിൽ ചോദിക്കാം നിങ്ങൾക്ക്. നിങ്ങൾ ഈ ഇടയ്ക്ക് ഇടുന്ന കമന്റില്ലേ ഡൗട്ട്, അത് ഞാൻ അവസാനം ആൻസർ ചെയ്യാം നെക്സ്റ്റ് ലെക്ചർ തൊട്ട്. ഇപ്പൊ എന്തെങ്കിലും നിങ്ങൾക്ക് ഡൗട്ട് ഉണ്ടെങ്കിൽ നിങ്ങൾക്ക് ചോദിക്കാം. ഓക്കെ, ഇല്ല എങ്കിൽ നമുക്ക് തൽക്കാലം സ്റ്റോപ്പ് ചെയ്യാം. നിങ്ങൾ എല്ലാവരും എന്ത് ചെയ്യുക, നമ്മുടെ ഗ്രൂപ്പുകളിൽ പോയിട്ട് നിങ്ങളുടെ ഫീഡ്ബാക്ക് ക്രിട്ടിസൈസ് ചെയ്തുകൊണ്ട് തന്നെ ഇടുക. എന്തെങ്കിലും പോരായ്മകൾ ഉണ്ടെങ്കിൽ പറഞ്ഞുകൊണ്ട് തന്നെ ഇടുക. ഇനി ഗ്രൂപ്പിൽ പറയാൻ ബുദ്ധിമുട്ടുണ്ടെങ്കിൽ പേഴ്സണലായിട്ട് മെസ്സേജ് അയക്കുക. then only we can improve for your convenience. ഓക്കെ, അപ്പോൾ നമുക്ക് നിർത്താലോ. താങ്ക് യു. ഓക്കെ, എന്താണ് ഡൗട്ട്? ഡൗട്ട് ചോദിച്ചോളൂ വിനായക്. You can unmute. I will let you speak. So now you can unmute. ഇനി അൺമ്യൂട്ട് ചെയ്യാം. പറ്റുന്നില്ലേ? നോക്കിക്കോ ഒന്നൂടെ.
ഹലോ സാർ.
പറഞ്ഞോളൂ വിനായക്.
സാർ, സംശയം എന്താണെന്ന് വെച്ച് കഴിഞ്ഞാൽ സാർ ഓർഡിനറി ഡിഫറൻഷ്യൽ ഇക്വേഷനെ പറ്റി പറഞ്ഞപ്പോൾ പറഞ്ഞല്ലോ ഒരു ഇൻഡിപെൻഡന്റ് വേരിയബിൾ മാത്രമേ വരാൻ പാടുള്ളൂ. ഒരു ഇൻഡിപെൻഡന്റ് വേരിയബിൾ മാത്രം വെച്ച് ഡിഫറൻഷിയേറ്റ് ചെയ്യാൻ പാടുള്ളൂ. അപ്പോ
അതെ 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 അതെ, ഒരു ഇൻഡിപെൻഡന്റ് വേരിയബിൾ ആണ് വരുന്നത്.
അപ്പോ കുറെ ഡിപെൻഡന്റ് വേരിയബിൾ വന്നു വെച്ച് കുഴപ്പമില്ല.
ഡിഫറെന്റ് വേരിയബിൾസ് വന്നു കഴിഞ്ഞാൽ, അതായത് ഇപ്പൊ ഒരു ഫംഗ്ഷനിൽ വേറെ വേരിയബിൾസ് ഉണ്ടെങ്കിൽ, വേറെ ഡിപെൻഡൻസ് ഉണ്ടെങ്കിൽ നമ്മൾ അതിനെല്ലാം കോൺസ്റ്റന്റ് ആയിട്ട് ട്രീറ്റ് ചെയ്യും. ഇൻഡിപെൻഡന്റ് വേരിയബിൾ എത്ര എണ്ണമെങ്കിലും ആവാം. ഡിപെൻഡന്റ് വേരിയബിളിൽ പല വേരിയബിൾസ് ആവാം. സപ്പോസ് യു ഹാവ് സേ എഫ് ഓഫ് എക്സ് വൈ, ഇങ്ങനെയെല്ലാം ആവാം. ഓക്കെ, നമ്മൾ ഡിഫറൻഷിയേറ്റ് ചെയ്യുമ്പോൾ അറ്റ് എ ടൈം ഒരെണ്ണം മാത്രമാണ് എടുക്കുന്നതെങ്കിൽ വിത്ത് റെസ്പെക്ട് ടു ഇൻഡിപെൻഡന്റ് വേരിയബിൾ ഒന്നാണെങ്കിൽ അതിനെയാണ് നമ്മൾ ഓർഡിനറി എന്ന് പറയുന്നത്. അതേസമയം നമ്മളിപ്പോൾ ചെയ്യുന്നത് ഈ രീതിയിലാണെങ്കിൽ ഡോ എഫ് ബൈ ഡോ എക്സ് ഇതും ചെയ്യുന്നു, പിന്നെ വൈക്കും ചെയ്യുകയാണെങ്കിൽ ദിസ് ഈസ് കോൾഡ് പാർഷ്യൽ ഡിഫറൻഷ്യൽ ഇക്വേഷൻസ്. ഇത് നമ്മൾ പിന്നീട് പഠിക്കുന്ന സാധനമാണ്, അന്നേരം ഡിസ്കസ് ചെയ്യാം. പാർഷ്യൽ ഡിഫറൻഷ്യൽ ഇക്വേഷൻ നിങ്ങൾക്ക് അറിയായിരിക്കും. ഇങ്ങനെ വന്നു കഴിഞ്ഞാൽ എന്ത് ചെയ്യും, വിത്ത് റെസ്പെക്ട് ടു എക്സിന് ചെയ്യുമ്പോൾ നമ്മൾ വൈയെ കോൺസ്റ്റന്റ് ആയിട്ടും വയ്ക്കും, വൈക്ക് ചെയ്യുമ്പോൾ എക്സിനെ കോൺസ്റ്റന്റ് ആയിട്ടും വയ്ക്കും. അപ്പൊ നമ്മളിപ്പോൾ പഠിക്കുന്നതെല്ലാം ഒരൊറ്റ ഇൻഡിപെൻഡന്റ് വേരിയബിൾ മാത്രമേ ഉണ്ടായിരിക്കത്തുള്ളൂ. നമ്മളിപ്പോ കണ്ടതിലെല്ലാം കണ്ടില്ലേ, ഡി വൈ ബൈ ഡി എക്സ്, ഡി വൈ ബൈ ഡി ടി, അങ്ങനെയൊക്കെ ഉണ്ടായിരിക്കത്തുള്ളൂ. ഓക്കെ,
ഹലോ സാർ. അപ്പൊ ഇപ്പോ ഡി വൈ ബൈ ഡി എക്സ് പ്ലസ് ഡി സെഡ് ബൈ ഡി എക്സ് എന്നൊക്കെ പറഞ്ഞാലും ഡി സെഡ് വേറൊരു വേരിയബിൾ ആണെങ്കിൽ
ഡി സെഡ് ബൈ ഡി എക്സ് അങ്ങനെ വന്നു കഴിഞ്ഞാൽ ഫങ്ഷൻസ് വ്യത്യാസം എന്നേ ഉള്ളൂ. അതായത് ഡിപെൻഡന്റ് വേരിയബിൾ മാറുന്നേ ഉള്ളൂ. അവിടെ ആ ഒരു കേസിൽ നമ്മൾ ഓർക്കേണ്ടത്, സേ ഇയാളുടെ ക്വസ്റ്റ്യൻ ഇതാണ്, ഡി വൈ ബൈ ഡി എക്സ് പ്ലസ് ഡി ഇസഡ് ബൈ ഡി എക്സ്. ഈ ഇസഡും ഈ വൈയും നമ്മൾ ഡിഫൈൻ ചെയ്തിരിക്കണം. സപ്പോസ് യുവർ വൈ കണ്ടെയ്നിങ് എഫ് ഓഫ് എക്സ് വൈ എനിത്തിങ്, നോ പ്രോബ്ലം. ഇസഡ് കണ്ടെയ്നിങ് എഫ് ഓഫ് എക്സ് വൈ എനിത്തിങ്, നോ പ്രോബ്ലം. അപ്പൊ നിങ്ങൾ ഡിഫറൻഷിയേറ്റ് ചെയ്യുമ്പോൾ ഇത് എക്സ് ഉണ്ടെങ്കിൽ മാത്രമേ ഇത് എക്സിസ്റ്റ് ചെയ്യുള്ളൂ, അല്ലെങ്കിൽ അത് വാനിഷ് ആയി പോകും. അപ്പൊ ഇങ്ങനെ ഒരു സാധനം വന്നു കഴിഞ്ഞാൽ പ്രശ്നമില്ല. ഇതൊരു ഫംഗ്ഷൻ ആണേ, ഈ ഫംഗ്ഷന്റെ അകത്തുള്ള വേരിയബിളിൽ എക്സ് കാണണമെന്നേ ഉള്ളൂ. അപ്പൊ ഓർഡിനറി എന്ന് പറയുമ്പോൾ ഇവിടെ ഉള്ള ഈ ഇൻഡിപെൻഡന്റ് വേരിയബിൾ ഒരെണ്ണേ പാടുള്ളൂ. ഓക്കെ, ഡിപെൻഡന്റിൽ എത്ര വേരിയബിൾ ആയാലും പ്രശ്നമില്ല. അങ്ങനെ വരുന്ന കേസിൽ നമ്മൾ പാർഷ്യൽ ഡിഫറൻസിയേഷൻ യൂസ് ചെയ്യും. ഓക്കെ, നമുക്ക് ഒരൊറ്റ വേരിയബിളിനെ മാത്രം ഡിപ്പെൻഡ് ചെയ്ത് പോകുന്നെങ്കിൽ അതിനെയാണ് നമ്മൾ യൂഷ്വലി വിളിക്കുന്നത് ഓർഡിനറി ഡിഫറൻഷ്യൽ ഇക്വേഷൻ. അതർവൈസ് യു വിൽ ഗോ ടു പാർഷ്യൽ. വേറെ ആർക്കെങ്കിലും എന്തെങ്കിലും സംശയം ഉണ്ടോ? ഓക്കെ, വൺ മോർ മെസ്സേജ്. ഓക്കെ, അപ്പൊ നമുക്ക് വൈൻഡ് അപ്പ് ചെയ്യാം. എന്നിട്ട് 2 മണിക്ക് അല്ലേ പറഞ്ഞിരിക്കുന്നത്, നിങ്ങളുടെ ഫീഡ്ബാക്ക് ഇടുക. എന്നിട്ട് 2 o'clock വി ക്യാൻ ജോയിൻ. നിങ്ങൾക്ക് ഞാൻ നേരത്തെ ലിങ്ക് ഒരു 1:55 ഒക്കെ ആകുമ്പോൾ തന്നെ ഒന്ന് ജോയിൻ ചെയ്തേക്കണേ. 2 മണിയാകുമ്പോൾ ഞാനിതൊന്ന് പിന്നെ ആരെയും പെർമിറ്റ് ചെയ്യത്തില്ല. അങ്ങനെ ആക്കി വെക്കാൻ പറ്റും. സോ ഓൺ ടൈമിൽ നിങ്ങൾ ക്ലാസ്സിൽ കയറുക. ഓക്കെ, ക്ലാസ് മിസ്സായവർക്ക് ഞാൻ യൂട്യൂബ് ലിങ്ക് പ്രൊവൈഡ് ചെയ്യും. ഓക്കെ, ബൈ.